organisms that interact by exchanging materials?
Couldn't have said it better myself. In fact, you're gonna have to say it again. What was the first word? An area?
Yeah, it's an area.
All right. I'm just say a place. And by place we mean like any place. The inside of this pen is an ecosystem for bacteria and stuff that floats around in the air, and it eats I don't even know what they eat, but it could be an ecosystem could be any place at all. The underside of my shoe can be an ecosystem. That bucket can be an ecosystem. The courtyard is an ecosystem. It's you guys think of deserts and tropical rainforest and the Arctic tundra and whatever as ecosystems, but anything can be an ecosystem. Your armpit is an ecosystem. So definitely. I'm just saying, it's anywhere, a place where living things interact with, I know I'm paraphrasing you now, Gary, but living and non-living components. How about living and non-living? What is it?
Substances.
Substances.
That's what it says in the book.
Living and non-living things. Living things. Ah, God.
Living organisms and non-living substances. That's what it's.
Okay. And what was and then there was a second part, right? There was something about blah blah blah.
By exchanging materials.
By exchanging materials, right? Exchanging materials sounds like a bank. It sort of is. Okay, so there's and this is something we've had since what? What was the first time somebody remembers hearing about an ecosystem? Like 3rd grade, 4th grade, 5th grade, 6th grade, something like that, right? And it's always the same thing. And then somebody says tropical rainforest, and then somebody says desert, and it's the ecosystems, right? But what we really have to start thinking about is what are the living organisms and non-living substances, and what materials are they exchanging? First of all, they're only really exchanging one thing.
Energy?
Yeah, pretty much. Well, sort of. In a way. I'll just say, I'm going to say sunshine. Because that's what it really comes down to. Sunshine and molecules. Sunshine and molecules, because that's what makes the plants grow, right? And that's, I know you hear that all the time. The plants are the basis of every ecosystem. Well, they are. It's because they are. Because take away the sunshine, and this is just a barren rock. There's nothing on it. It's just dead rock. But add some sunshine and a few million years of erosion and whatnot. Oops, green sun. And then now you really got something, because the whole thing is that it comes down to energy. The energy. The energy is what makes the plants grow. You heard about me? It's all about the energy, you all, and it really is. What you say is that it all comes down to the sun, because without the sun, then there's nothing for, oh God, here we go. What the hell is that? Nothing. It's a rabbit, all right? It's a rabbit. There's nothing for the rabbit to eat without the sun, right? Because rabbits eat plants. And rabbits aren't going to eat plants if there's no sun. And certainly, oh God, I know how to draw so few animals. What eats rabbits? Wolves.
Oh,
Give me something a little lower on the food web that eats rabbits.
Fox.
snake.
fox. I'm gonna try fox.
Owls.
Owls. Now, because nothing eats owls. Nothing eats owls. You ever eaten an owl?
No, but so
There's an expression. I knew this guy, and he's the toughest guy I ever knew, and he was telling me about the toughest guy he ever knew, and he said he was as tough as a boiled owl, and that's true. You know how you eat owl? I'll tell you how you eat owl. You take a big pot of water, and you get it boiling, right? And you throw in the owl, and you throw in a boot, a leather boot, and it's got to be leather. And you throw it in there and you keep it boiling for 5 days, and you have to keep replacing the water, and because it'll boil away, and you keep replacing the water and boiling that shoe and that owl for 5 days, and then after 5 days you drain all the water out, take the owl out, and you throw it away, and you eat the boot because it's going to taste better than the owl.
Well, Google says foxes, cats, and birds of prey as in eagles.
As in eagles eat
Yeah.
eat rabbits, or they eat owls?
Apparently.
Which
Fuck.
one?
So like foxes. What were the other things you said?
Cats and
Eat
birds.
owls?
Yeah.
Really? Learn something new every day. I did not think anything ate owls. Okay. All right. Well, we're gonna change our food web then because Quincy did research here. So okay. So here comes. I really stink at drawing talons too, and owls for that matter. Hold on. How does this work?
You don't have to make it look like it's trying to change it.
It's not bad owl head. Oh, that was bad owl nose.
Was it far now?
Wait, you should have his wings out. He's doing good until then. All right, no, he doesn't have. He's just
Now he's on.
he's Beavis.
I have the greatest content.
Yes, I guess I deserve that. All right, and so here comes the owl. Right, but seriously, it's the sunshine, feeds the plants, feeds the rabbit, feeds the owl, and then what? A fox.
Fox.
This is going to be a pretty big fox. Oh God, help me.
What a dinosaur.
Quincy told me.
No, that wasn't me.
No, owls. Nobody said owls eat rabbits.
Oh, wait, yeah, owls eat rabbits? What are you talking about? Owls don't eat rabbits. Owls eat rabbits for sure. That part is not in question to me. It's the fox eating the owl that I have to just sort of take on faith here. I think that's just kind of
the
dumb.
box.
It's a foxy gator. All right,
Flash TV.
fox. Okay. Anyway, yeah. So, fine. The point is, though, all right. The materials they're exchanging. First of all, sunshine moves through all this because really, when you eat anything, what you're eating is matter that got put together by plants. Plants take carbon dioxide out of the air. It's the most amazing thing. They take carbon dioxide out of the air and they turn it into themselves. It's an awesome trick. Like every time you look at a tree, this is the difference between what you learned in third grade and what I want you to think about now, is that every time you look at a tree, I want you to realize that started as a seed and not a single ounce. Maybe in a 1 ton tree, maybe a few ounces of that tree came out of the ground, like a few nutrients and stuff like that, like nitrogen and a few things, but 99% of the weight of that tree was pulled out of the air as individual carbon dioxide molecules that are floating around and packed together into sugar and into starches and into wood and into all these other things. Hello. And that's how all this stuff happens. It's amazing, you guys. It's when we say life's amazing, like, I'm not kidding. I know it's boring to you guys, but honestly, if you stop and think about, like, whoa, pulling molecules out of the air, turning them into a thing, and then that basically gets turned into a fox Just take my word for it.
And
That's
then
fine.
that doesn't get tornado fox eats it.
Well, but I mean, it's the same. I mean, the thing is, there are molecules. There are molecules from this flower that are in this fox.
And the fox grows because of it, right?
Yeah, right. So every step along the way, like this has molecules from the flower, and then about 10% get passed on every time. Most of it gets used as energy and just to like run the body, and half of it gets crapped out as waste, and then about 10% of it gets passed on to the next level. And but still, it's like that's why it takes a whole lot of grass to support this ecosystem, a whole lot of plants, because only 10% of that biomass moves on to the next level. That's why when you look at like the numbers, we're going to talk about this a little bit later. But if you do a pyramid of the numbers or the mass of every level of a food web like this, right? Do you remember what these levels are all called? How about that from biology? Those people who didn't have biology with me, because I think we skipped this last time when you guys had biology with me. Do we do ecosystem? What's that? Consumer? Well, these folks are all consumers because they have to eat. They have to eat stuff to get their food. Another word for consumer. Well, what are these called then? The ones that make their own energy from the sun.
Producer.
Yeah, producer. Right? You got your producers, you got your consumers, and we've got a name for these. And I'm only going to do about 5-10 more minutes here, folks, so don't worry, this is not going to go on forever. Your herbivores, the first level, are called primary consumers. Oh, not dry erase. Oopsie. Primary consumer, meaning first level. The way you write primary, by the way, primary, secondary, is a 1 with a little degree mark next to it. That means primary. And then you got your secondary consumer, right? Secondary consumer. Which is a 2 with a little degree mark next to it. That's how you write secondary. And does anybody know the word for this level? Tertiary, very good. Tertiary consumer. And then I suppose there is such a thing as a quaternary consumer. But the thing is that it takes a lot more. If you look at the different levels of an ecosystem, primary, secondary, tertiary, quaternary, because only 10% of the energy moves on from level to level. This is your rabbits here, I guess. Oh god. Actually, that rabbit, no, that's a snail. It was a good rabbit for a second. Oh god. That's not bad. That's not good. So there's a lot less mass of rabbits than there is of producers because, again, only 10% of the energy moves on. The rest gets pooped out or used to make the rabbit just run and breathe. And then you got your owl here. Oh god. Well, that's not bad. Okay, I know what that is. That's supposed to be another owl. And here's your fox. So that's why there's a limit on how many top predators you can have. This would be the top predator, is what you call it. Usually the one at the top is a carnivore, an obligate, meaning that it has to eat meat. There's not a lot of herbivores at the top of the food chain. And but anyway, that's why an ecosystem can only support a certain number of top predators. That's why you only see a certain number of, like, I don't know, bears or whatever. Low.
Rose villages or something.
Sure. All right, folks. So that's pretty much it. Let me ask one other question. So these guys are exchanging materials, and which means that now exchanging materials is just another way for saying they get eaten. So if you ever get eaten by a shark, I want you to think the last thing you think to be exchanging materials with the shark.
That's my last thought.
Exchanging materials. Damn it. I don't know. But so that's the thing. So between the energy, this is the last question. Between the energy in an ecosystem and the matter, the molecules in an ecosystem, one of these is a cycle. One of these is one way. So meaning like one of these, gets exchanged over and over again and recycled by the ecosystem. Which one of those two things was that? Which one of these gets recycled? The matter, right? The matter is always recycled. Because, what are these guys all going to become eventually? What part of the ecosystem did we leave out? I know I said this was the last question before. This is really the last question. Sort of, in the ground, kind of, like, what about the ground? What part of the ecosystem are we leaving out? What organisms are we leaving out here? Decomposers, right. Everybody eventually is going to turn into a big pile of brown goo. Ultimately, that'll be what rabbit looks like. And I don't just mean poop, I just mean like they're eventually going to get recycled back into earth materials by decomposers, bacteria, fungi. The decomposers are at the bottom of the whole thing. And they get fed by everybody, and they recycle all the materials. So all the carbon atoms, all the nitrogen, all the phosphorus, all the sulfur, all the hydrogen and oxygen in these animals and in these plants, it cycles around and around the ecosystem, because eventually this goo that used to be a rabbit is going to turn into plants. And it's going to turn into rabbits again, then on and on. But the energy only moves one way. The energy moves through the ecosystem. It moves through here, and there's less. More and more and more of it gets harvested until there's literally like none left. It's just all dissipated as heat. And that is how ecosystems work. So all right, so that's all I got about that. We'll just keep it at that for the day. And